In problem 3, we're going to construct a 99% confidence interval for a population mean. In this problem, we have a survey of 36 and a sample mean of 45.35. The population standard deviation is assumed to be 1858. So this sentence right here implies that we have a sigma known problem, because sigma is the population standard deviation. As such, we use a z stat. So I'm going to copy this information into Excel. Okay, so the sample size is 36. The sample mean is 45.35. The population standard deviation is 1858. And the confidence level is 99%, or 0.99. So 99% or 0.99. The variance of the sample mean is different from the variance of the variable. The variance of the variable is equal to the square of the standard deviation. In this case, 345.2164. The variance of the sample mean is equal to the variance of the variable divided by the sample size, 9.589344. The standard error of the mean, of the sample mean, another name for it is the standard deviation of the sample mean. So to calculate a standard deviation from a variance, you take the square root. So we're just going to simply take the square root of the variance of the sample mean. Next, we have to compute the values of the confidence interval. So at my teaching page, you can download PowerPoint 8, which you already have up. The confidence interval is the sample mean plus or minus z times sigma over square root of n. Sigma over square root of n is the standard error, and you multiply the standard error by z to get the margin of error. So this right here is the margin of error, and this part here is the standard error. So I'm going to go ahead and copy and paste that into Excel. Okay, after pasting in Excel, I want to circle the part that represents the standard error. That is the standard error that we calculated right here. This right here, that circled part, is the margin of error. So the first thing we have to do is we have to get the area in each tail of the standard normal distribution. Alpha divided by 2 is the area in the upper tail of the distribution, and alpha divided by 2 is the area in the lower tail of the distribution. Recall that 1 minus alpha is 0.99. So alpha is 1 minus that, 0.01. And because the confidence interval has 2 values, we have to divide that by 2. We have to divide the alpha by 2. So alpha divided by 2 is equal to 0.005. The z value is found in either the standard normal table or the infinity row of the t table. I like to use the infinity row of the t table because you have 3 decimal accuracy. So I'm going to go ahead and open up the tables in the appendix of the textbook. In the infinity row of the t table, in the column corresponding to 0.005, the z critical value is 2.576. I'm going to paste that back into Excel right here. So now all I have to do to get the margin of error is multiply the standard error by the z value. So my margin of error is 7.977013. The confidence interval is just the sample mean plus or minus the margin of error. So all I have to do here is take the sample mean and then subtract off the margin of error. So my lower limit is 37.37299. My upper limit is the sample mean plus the margin of error. So we're 95% confident the true population mean is between these two values. Now it's just a matter of copying and pasting things into this Engage Now problem. So the point estimate of the population mean is x bar, and that is right here. And we're only going to copy the 45.35 because this, with this word here, 1,000, this is 45,350. And it says 3 decimal places, so I'm going to add a 0. The standard error we computed to be that, but we only need 3 decimal places, so I'm going to shrink that down to 3 decimal places. To compute the margin of error, the standard error is multiplied by the critical value. The critical value for the confidence interval can be found in the infinity row of the t table, which we did, remember. And the critical value was what? 2.576. Using 3 decimal places. That's one reason why we have to use the infinity row of the t table. The margin of error we computed to be equal to that, but we only need 3 decimal places, so I'm going to shrink that down to 3 decimal places. Copy, and then paste that into Engage Now. And the 99% confidence interval is blank to blank. We only need 2 decimal places. So I'm going to shrink these down to 2 decimal places. So the first one's 37, and the other one is 53.33. Let me check my work, and I should get everything correct. And I do. Now, how do we interpret the values of the confidence interval? Suppose we replicate this experiment. We gather 1,000 random samples, all of sample size 36. We're going to have 1,000 different measures of the sample mean. Every time we compute a new confidence interval from the 1,000 unique sample means, in this case 45.35, we can construct 1,000 unique confidence intervals. And because we built a 99% confidence interval, we're 99% confident that the true population mean is within each of these 1,000 confidence intervals. In other words, if we construct 1,000 confidence intervals, 990 of them will contain the population mean, thing that we cannot estimate, mu. 10 of them will not contain the true population mean.